Hello, and welcome back to BlueHat CyberSec Academy. In this lesson, I am going to the following topics. First, network segmentation, specifically the Demilitarized Zone, or DMZ. Next, we'll take a deeper dive into DMZs. After that, we'll cover segmentation for embedded systems and IoT. And lastly, segmentation for embedded systems and IoT deeper dive. These topics are, part of Domain 4. Network security concepts in the Certified in Cybersecurity, or CC, exam, and they're super useful for both exam preparation and for building a strong cybersecurity foundation. So, let's begin. Network segmentation is an effective way to achieve defense in depth for distributed or multi-tiered applications. One common practice in security architecture is the use of a demilitarized zone, or DMZ. With a DMZ, host systems that are accessible through the firewall are physically separated from the internal network. This separation can be achieved by using secured switches or by deploying an additional firewall to control traffic between the web server and the internal network. Application DMZs, also known as semi-trusted networks, are frequently used today to limit access to application servers to only those networks or systems that have a legitimate need to connect. Now, let's move further into the specifics of DMZs. A web front-end server might be placed in the DMZ while retrieving data from a database server located on the other side of the firewall. For example, consider a network managing client personal information. Even if the data is encrypted or obfuscated, it is crucial to ensure the network is completely segregated from the rest of the network. Secure switches should allow access only to authorized individuals, and only authorized personnel can manage firewall settings and control traffic between the web server and the internal network. In settings such as hospitals or doctors' offices, networks are often segregated to protect patient information and billing systems, while electronic medical records may reside on a separate network. Web-based applications for medical record services often use a demilitarized zone or segmented areas, sometimes behind the firewall, to protect critical information. It is worth noting that while this course will not explore the specifics, some networks use a web application firewall, or WAF, instead of a traditional DMZ. A WAF has both internal and external connections, similar to a firewall. External traffic is filtered by a traditional or next-generation firewall, while the WAF monitors all incoming traffic, encrypted or not, for malicious behavior before passing commands to an internal web server. Let's now move on to network segmentation for embedded systems and IoT devices. An embedded system is a computer implemented as part of a larger system, typically designed to perform a limited set of specific functions within the larger product. Examples include network-attached printers, smart TVs, HVAC controls, smart appliances, smart thermostats, and medical devices. Network-enabled devices are, portable or non-portable devices with native network capabilities, usually connecting over a wireless network provided by a mobile telecommunications company. Examples include smartphones, tablets, smart TVs, streaming media players like Roku, Amazon Fire TV, Chromecast, network-attached printers, and gaming systems. The Internet of Things, or IoT, refers to devices that communicate over the Internet with each other, or with a control console to monitor and affect the real world. IoT devices often include smart home equipment and industrial environmental control systems adapted for consumer use. Embedded systems and network-enabled devices communicating with the Internet require special attention to prevent malicious use. Because embedded systems often control physical mechanisms, a security breach could cause harm to people or property. These devices frequently have multiple access routes, such as Ethernet, wireless, or Bluetooth, so it is important to isolate them from other network devices. Logical network segmentation can be implemented using VLANs, MAC addresses, IP addresses, physical ports, protocol rules, application filtering, routing, and access control management. Proper segmentation ensures that IoT environments remain secure. Now let's take a deeper dive into embedded systems and IoT security considerations. The very characteristics that make embedded systems efficient also pose security risks. These systems often control physical mechanisms, such as valves for water, steam, or oil. Many are hard-coded or permanently written to memory chips to simplify operation of mechanical parts. Since embedded systems often connect to corporate networks using TCP/IP, the same protocol that powers the Internet, they can be vulnerable. Without proper segmentation, anyone on the Internet could potentially control these physical mechanisms. Segmentation is critical because it ensures that even if a corporate network is compromised, attackers cannot access physical controls on embedded systems. Another challenge is the lack of system updates. Many embedded systems require physical replacement or manual reprogramming of chips to patch vulnerabilities, which is often costly and honestly impractical. Consumer IoT devices, cameras, light bulbs, speakers, refrigerators, and more introduce convenience, but also risk. While reputable brands often provide updates for security vulnerabilities, smaller manufacturers may not. When connected to corporate networks, these devices can create easy entry points for cybercriminals. Proper segmentation ensures that even if an IoT device or embedded system is compromised, attackers cannot access corporate data or systems. That's all for now. Thanks for tuning in. Keep the momentum going by checking out the next video in the series, and if you haven't already, please like, share, and subscribe to BlueHat CyberSec Academy.